Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part 2 video from the chapter of refraction of light at plane surfaces, I like to teach experimentally verification of Snell's law. So already we discussed that what is the Snell's law or Snell's law of refraction. In our previous video, I clearly tell that how many laws of refractions are there? Two laws of refraction are there. The first one is the incident ray, comma, the refracted ray and the normal all lie in same plane at a point of incidence at the surface of the two media. And the second one is the ratio of sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of media. This is the second law of refraction. The second law of refraction was given by which scientist? William Bode Snell. That's why the second law of refraction we are also called Snell's law of refraction. And what is the formula of Snell's law? We know that I explained in previous video. Sin I upon sin R is equals to mu Rn. Anyone who are using that? So then again here sin I upon sin R is equals to mu2 upon mu1. Why? Because of here mu of 2 1 we can set that. So means okay, in morning video I says that the light is traveled from where to where? Air to semicircular glass slab. Air is the rarer medium, glass slab is the denser medium. According to relative refractive index, the refractive index of the glass slab with respect to the air, that is the meaning of that. Here, air is we can say as a first medium and glass slab we can say as a second medium. That's why, so the refractive index, mu is the refractive index. Refractive index of the second medium with respect to the first is nothing but what is the meaning of this one? Light travel from first to second, means you can find which is refractive index. Okay, second medium refractive index. So mu of 2 1 is nothing but already I proved in the relative refractive index mu2 upon mu1, means relative refractive index we are defined in the two ways. Once you remember about that one, the first one is the ratio of speed of light in the first medium to the speed of light in the second medium is also called relative refractive index based on the speed concept. But based on the refractive index of the two medium, how we can define means the ratio of refractive index of the second medium to the refractive index of the first medium we are also called relative refractive index. That's why mu of 2 1 we are write that mu2 upon mu1. So either this one or after this we can do the cross multiply. Mu1 sin I equals to mu2 sin R. This is okay. So most of the cases during the examination, so they are asking that define Snell's law of refraction or defines Snell's law. At that time you write the definitions or statement and you can write either this one or this one. But in MCQ, mostly in the competitive examination side, we are observing that so among the following which is represented the Snell's law, sometimes they are given this one, sometimes they are given this one. That's why you keep these two in your memory, so automatically you can easily understand that. Now there is really sin I upon sin R is constant or not. That is already in the previous video I clearly explained with the semicircular glass slab method. Now in this time I would like to explain the same concept in case of which one? Okay, rectangular glass slab method. With help of the rectangular glass slab method also we verify sin I by sin R is equals to constant or not. And finally it is equals to the refractive index of the second medium or not. That is also we discussed. So listen, if we can do this experiment like the previous one, to find a sin I by sin R is equals to constant. What is our one? Sin I upon sin R is equals to constant. This is experimentally we proved initially with the semicircular glass slab and also I proved with the rectangular glass slab also. First of all, we can take a white chalk. It is fixed on the wooden board. Now we can take a rectangular glass slab. It is placed at the middle of the paper and draw its boundaries with help of the pencil. And the corners of the glass slab we can see as A, B, C, D. Or the vertices of that ones we can see as A, B, C, D like this one. So now we remove the glass slab and for the AB horizontal surface of the glass slab we draw a normal N and dash. N and dash is the normal for the AB surface, where the N and dash will be meet the AB surface, that is we can say as a O. O is coincide point or intersection point for N and dash and AB. Now what we can do here means so now we draw an incident ray by using a protractor. Means a protractor we placed it like this one. Means in the protractor M dash is there. The M dash of the protractor is exactly coincide the AB and N on the protractor is exactly coincide with the N. Here you are observing that ON is the normal for the here which one is there 8 and ON dash is present where inside the slab. That's why ON is the normal for rarer medium, ON dash is the normal for denser medium of the glass slab. We can say that. So now we place the protractor as shown in the figure like this one, and with help of the protractor we draw an incident ray. So initially here we taken that what is that one, for example 10 degrees. So it is the 90 degrees, means here 90, 80, next 70, 60, 50, 40, 30, 20, 10 and 0. It is the 0 means it is the 90. That's right. So here at the 80 means along the 80 degrees angle we draw for here 90 is there, here 80. That's right. Along this one you draw one line like. Remove the protractor and this line is joined with O. So that's why this is represented angle of incidence. What is the angle of incidence? 10 degrees. Now on this incident ray, it is the incident ray. Now on this incident ray we fix two pins P and Q in vertical mode. Listen very carefully. After draw the incident ray with help of the protractor. What is the incident ray? 10 degrees. After that, now we can take the two pins. The two pins we fixed on the incident ray at 5 cm distance in vertical mode. Vertical mode means like this one. It is the paper, it is the line. On the line, two pins we can keep in vertical mode. The distance between them is not exceed more than 5 centimeters. And not less than the 3 centimeter. At that time you are observing very clearly. Now after completion of that one, what we can do means again replace the rectangular glass slab in this within the boundary. After replacing the glass slab within the boundary, you can come to the other side of the glass slab. So here the according to the boundaries of this glass slab, how many horizontal surfaces are there? Two. One is the AB, another one is the CD. So in the side of AB, which ray we consider incident ray? That's why now we can come to the other side of the glass slab is nothing but CD side, and we can draw an emergent ray with help of the PQ. Sorry, with help of the incident ray and the PQ. Now means after coming to the other side of the glass slab is nothing but CD side. Now we can take the two pins. The two pins we fixed in the side of the CD along the straight line of the PQ. Means after placing the it is the R, it is the S. After fix the R and S pins in the side of CD. Now this all the pins are we are observing it is appear in a straight line or not. So how you are observing that our fixing two pins R and S in the side of CD is exactly in the same straight line with the PQ means. So if we can observing the head of the S pin, all the four pins are appears head of pairs. Head of pairs means okay, like this one. Like this one. So it is the P, Q, R, S. So means when you can see the okay head of the S pin. So after fixing the R and S, these all the pins are appears in a straight line like head of pairs. Means S, it is R, it is the Q, it is the P. All are appears in a straight line manner only. So when all are appears in a head of pairs in a straight line, then you fix exactly. So the incident ray will be passing through the glass slab and come outside through the which one CD. That's why these two pins are represented the emergent ray direction or path. Now we can remove the two pins and okay, you draw a line. This line is we draw a straight line. This line will be extend it up to the CD. Where this line will be meet the CD at that one, we can draw one normal for the CD. This is M dash. It is the O dash. Listen very carefully. So N dash is the normal for AB surface. M dash is the normal for CD surface. The intersection of N dash and OB where AB we are called O. The intersection of M dash CD we are called O dash. Okay. So now here this is what is that one? Angle I2 or angle of emergency. It is angle I2. So it is I or I1 we are considered that is okay. So it is the angle of incident, it is the angle of emergency. But this angle of emergency is not important to us. Okay, this is used in the latter concept, that is okay, experimentally determine the nature of the image with help of the glass slab and find the lateral shift of the glass slab. But now what we can do means, so now we can draw an imaginary line to join from O to O dash. Okay, here we are observing that. So here this is the incident ray because of above this AB surface what is present in A, it is which medium? Radar medium, and B2C in this thickness which is the denser medium because of it is a glass slab. That's why incident ray will travel in the A at the AB surface at point O. The light is entering into the denser medium. That's why when the light is travel here, it is the radar medium. This is called angle of incident, and this is the refracted ray. So this is the normal. That's why the angle between refracted ray and normal is called angle of refraction. This value we can find by placing a protractor after removing the glass slab from this one. Once again, listen very carefully. What we can do here means, first of all, we can take and rectangle a white sheet of paper. It will be fixed on the drawing board. Now we can take a rectangular glass slab. The rectangular glass slab we place at the middle of the paper and draw the boundaries with help of the pencil. And the corners of the rectangular glass slab we can say as A, B, C, D. Now remove the glass slab. So from the figure you are observing that the glass slab will be having the two surfaces mainly horizontal. One is the AB horizontal surface, another one is the CD horizontal surface. Now we draw a normal for the AB surface at any one point. So here N we draw N dash line. It is the normal for AB surface. This N dash where meet the AB surface, that is the point of intersection we can say as O. Now we place a protractor okay on the AB surface action in the figure. Like means the M dash on the protractor is exactly coincide the AB and N are 90 degrees on the protractor exactly coincide the normal in this one. That's why after placing the protractor, so with help of the protractor we draw an incident ray. What is this one? 10 degrees. Now remove the protractor from their position and we can extend the ray up to the O. So that's why this is the incident ray, it is the normal. The angle between incident ray and normal is called angle of incident. What is this value? Initially we can say that 10 degrees. Now we can take two pins. The two pins we fix on the incident ray at different position. The distance between these two pins is not exceed more than 5 cm and less than 3 cm. That's why you fix the two pins on the incident ray in vertical mode at certain suitable distance. One is we can say as P, another one we can say as Q. After that, now we can rearrange the rectangular glass slab within the boundary on the paper. Now we can come to the other side of the rectangular glass slab is nothing but CD side, and we fix the two pins R and S along the straight line of the PQ. How it is appears by seeing through the CD surface is nothing but simply you are observing that. Okay, so it is the drawing paper. On the drawing paper, we place the glass slab here. The glass slab means it is a transparent. We know that this dust we can see as a glass slab. So here AB, it is the CD surface. At the AB surface, we draw the normal. Okay, for the normal, we consider one incident ray. Here two pins are there, P and Q. Now, after doing this one, you come to the CD side and we are observing the incident ray and two P and Q pins. Now we can fix the two pins in the side of CD, that is R and S. Okay, now these two pins we fix it exactly in the straight line of P and Q along the incident ray with respect to that. Then after that, now we put the two pins R and S, we draw the circles. These two points are joined with a straight line and this is extended up to the CD line. When it is meet the CD line, that point we can say as a O dash. At this intersection, we draw one normal for the CD. So this one it is represented emergent ray. So it is the incident ray. You know that. Okay. Now here, instead of this one also, we are using the laser light. If the laser light will be fall here, the laser light will be travel inside this one and come outside. So it is the incident ray. The part of the light which is travel inside the glass slab, that is the refracted ray, and the part of the light will become outside, that is called emergent. Emergent means come outside. Here the light is enter, here the light will become outside. That's why this is represented the emergent ray. Now remove the glass slab from that one, and now here what we can do, we can join the O and O dash with a straight line. If you can join the O dash, this line is represented, O dash line is represented the refracted ray. Is it correct or not? This is the incident ray, it is the refracted ray. So this is the incident ray, this one is light. But here, so here I am observing that O dash is the refracted ray, O dash is the normal for denser medium. That's why the angle between O dash and normal gives the angle of refraction. That's why here angle of incident is 10. From this one, by placing the protractor in the lower side, we can find the angle of refraction like previous mode. So we draw a tabular form. Angle I, angle R, sin I, sin R, sin I upon sin R is equals to constant. This one, same like this one. So now we can conduct the experiment by taking another charts and we can draw first 10, 20, 30, 40 like this one. So for every case, what is that for 10, 20, 30, 40. For 10, experimentally we can find 6.5, 13, 9.5, 26. So the angle of incident in the air is 10 when the light is traveling through the glass slab or semicircular glass slab. What is the angle of refraction? 6.5, 20, 13, 13, 19.5, 40, 26. That's why you can find by using the which one? Natural tangent. By using the natural tangent, we can find the sin I value, which means sin 10 and the sin 6.5. That's why sin 10 upon sin 6.5, one value will be given. Like the same, we can do this one, and finally we can find the average of this value. Average of this value will be always constant. Means here 1.5, 1.5, 1.49, 1.5 something like this one will become. So that's why we are observing that each and every cases the value is what is that one 1.5. And that's why what is the average value? When we are observing the average value of this all that one, it is always constant. Means simply, so 1.5 something, 1.5 something, 1.49 something, 1.5 something. Means 49 is nothing nothing but nearly 5. That's why all the first, okay, means after the decimal, the first value we can say 1.5, 1.5, nearly 1.5, 1.5. That's why in every case, sin I upon sin r is equals to constant or not? Yes, absolutely it is right. That's why sin I upon sin r is constant. That constant average value we are observing that it is equal to which one? Okay, refractive index of the glass slab. This is the way of method. With help of the rectangular glass slab, we can find which one we can prove Snell's law of refraction, that is sin I upon sin r is always equals to constant, and that is equals to the refractive index of the second medium. Tomorrow I try to conduct this experiment practically. Means I will be uploaded a practical demonstration about Snell's law of refraction with help of rectangular glass slab. And also I said with help of this concept we are also prove one more concept. What is that one? Determine the nature of the glass slab, image of the glass slab, and find the what is the lateral shift. And also one more important thing is there, the what is that one means the deviation produced by the glass slab is what is the value, that is the 0. So how it is correct we are also explain, means I will try to explain with help of a practical demonstration next coming video. So once again listen very carefully. So our topic, mainly our topic is experimentally verify Snell's law of refraction, or experimentally verify sin I upon sin r is equals to constant. So what is the Snell's law? The ratio of sine of angle of incident to the sine of angle of refraction is always constant for a given pair of media. Means sin I upon sin r is equals to constant. So really it is correct or not, we can verify in the two ways. The first one is by taking the semicircular glass slab and laser light method, and the second one is rectangular glass slab and two pins method. With help of this one, either the first activity or the second method, finally we can prove sin I upon sin r is always constant. So all of you students listen very carefully. Most of the students, I hope you are understanding at a time, because of most I will be try to my level best to understand at a time only each and every topic. If any one of the student is not understanding at a time, I given a small advice. What is that one means? You try to see my video 3 or 4 times through the YouTube, because of it is a offline mode. That's why it will be in the always available in the YouTube mode. Then you can see 3 or 4 times. After that only, so if you cannot see my video 3 or 4 times, then automatically you can understand each and every topic, even it is small also. Then after that you can start to write running notes about that particular topic. Without seeing the video, when you can start to write the running note based on one particular topic. So in the middle of the topic, so the answer will be not strike in your mind at any point. Again, once you can watch the video completely and again you can start, then automatically you try to complete the running notes in your own only. Why I suggested you can follow this type of method means most of the cases I will be try to avoid by heart method. Why? Because of if you can follow the by heart method, then what will be happen? So if you can by heart the method, number of answers are in your mind. When you are going to the examination, the concept is not in your mind, just only the answer in your mind. That's why, so if you are asking the question in the tilted mode, you cannot understand, then finally you cannot answer the question. But if you are understand the only concept only, that's why the question they are asking in any type of mode about that concept, immediately the answer is striking in your mind. Means when you can see the question, so this is related to this topic, that's immediately you can write that answer. And the same way, by heart method is not good for every time. That's why, so if you can write the running notes without seeing the video, means what will happen? You can prepare the answer by your own only. If you can prepare the answer by your own, then automatically what will happen? So if they are asking the question at any time, you are prepared to answer your own only. Due to that, then automatically you can write that answer clearly without any fear and without any mistake. That's right. So I always encourage the this type of mode, but not encourage the by-hearted method. That's why I hope all the students are understanding my feeling, and you can try to write the running note without seeing my video. When after seeing 3 or 4 times or at a time, you can close the video and try to write the running notes. If any doubt is there, again you can come. At the same one more thing. So when you can see these videos, if you have any doubt about any topic, through the WhatsApp you can ask me. I will be given some more clarification about that particular concept through the WhatsApp only. So thank you.